Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's say today's problem, shortest path in weighted undirected graph. Okay. So what this problem is saying is we'll be given a weighted undirected graph. And what we want to do is we want to find the shortest path from node 1 to node n, which is 5 in this case. Okay. That's what we want to do. Now, how can you solve this, right? So they are also saying that we'll be given the distances as well. Okay, from one node to another will be given distances as well. So using these distances, we want to have a path which with shortest distance from node 1 to node 5. That's what we're saying. Okay, so when such problems come, right, when you want to find shortest path in a graph, right, so the very famous algorithm which comes in mind is Dijkstra's algorithm, and we are going to use the same. Okay, so in Dijkstra's algorithm, what we are going to do is we generally solve the Dijkstra's algorithm using priority queue. Okay, so we'll create a minimum heap priority queue. Okay, which will give us the minimum distance. Okay, and we'll be having this two arrays, distance and parent array. Okay, now what the ask is, what you want to return. For example, in this example, the shortest path is what? 1, 2, 4. This is the shortest path. Okay, and what is the distance of the shortest path? It is 1 plus 3, right? 3, right? Plus 1 here, this one, right? Which is 5. Okay. So what the problem is asking us, we want to return the distance first, followed by the nodes in the path. So what are the nodes in the path? The shortest path, 1, comma, 4, comma, 3, comma, 5. So this is the answer we want to return. Okay. Now how to solve this problem, right? Using Dijkstra's algorithm. Okay, so we'll see that. Okay. So what we're going to do is, since we want to start with this node 1, right? So we will also you see, right? Also you see this distance array, it is initialized with infinity. Okay, so we will as we are starting with node 1, so we will initialize this node 1 position with 0, right? The distance between 1 and 1, it is 0. That is why. And also we are going to add what in this priority queue? We are going to add a pair of what? A distance and the node, distance and the node. So from node 1 to 1, the distance from node 1 to this particular node, that's what we are going to add in the priority queue. Okay. Now what we are going to do is, okay, now we will run a while loop until this priority queue is empty. So first, what we are going to do is we are going to pop this out. We are going to pop the pair with the minimum distance. So what is the minimum distance here? It is 0 and 1. Okay. Now what we are going to do here? Okay. So yeah, so we pop this out. Now what we are going to do is we are going to we are going to uh, process the neighboring nodes of this one. This is node, right? This is node value. So what are the neighboring nodes? Neighboring nodes of one are 2 comma 2. So let's process this. What is 2? This is the distance from 1, okay, to this node 2. Okay, this is the distance. Okay. Okay. So what we are going to check? We are going to add this 0 plus 2, right? 0 plus 2, that is from node 1. What is the distance to node 2? It is 2. It is 2. And we are going to check what? For this particular node in this distance array, what is the if this particular distance, if it is lesser than whatever it is there in the node in the position 2. Yes, it is infinity, it is definitely lesser, so we are going to update this 2. Okay, and also what we are going to do, we are going to add this in the priority queue also. Okay, since we have found a pair with short distance. Okay, so 2 comma 2, we are going to add this. Okay, apart from this, we are also going to update the parent. Okay, of this 2, of this node 2. Okay, of this node 2. So what is a parent? So whatever is we are coming from the current node, right? This is a current node. Okay, so we are going to update 2 to 1. So from 1 we have found a shortest distance to node 2. Okay, and that is why 1 will be the parent of 2. Okay, so this parent array will help in forming a path. Okay, which we want in the output. Okay, the shortest path, forming the shortest path. Okay, so we did that. Now what we're going to do, we'll process the next particular neighbor. Okay. So what is the next particular neighbor? Okay. So this is the distance. Okay. From node 1. And this is the destination distance. That is from 1 to 4. Okay. From 1 to 4, what is the distance? It is 1. Okay. So what we're going to do now, we are going to, so what is the current distance? Current distance is 0. Current distance is 0. And current node is what? 1, right? This right? So this is the neighbor of this one, right? This is the neighbor of this one. So what are we going to do? Current distance 0 plus 1. This 0, right? 0 plus this 1. Okay. It is 1. Okay, 1. So from 1 to 4, the distance is 1. We are going to check what is the distance at position 4. Okay, we are going to check whether this particular distance, if it is lesser than this one, definitely it is lesser. So we are going to update with this particular distance. So since we have updated, we have found a smaller distance. We are going to add this pair into the priority queue, into the priority queue. Okay, into the priority queue, and also we'll update the parent as well. So for this node 4, the parent is 1 since we have found a lesser distance. Okay, since we have found a lesser distance. Now we are done processing the neighbors of 1. Okay, we are done processing the neighbors of 1. Now we'll go to the priority queue in the while loop, and we are going to pick up the pair with the minimum distance. So out of these two pairs, right? Out of these two pairs, which is the minimum distance? This one. 1 comma 4. 1 is a distance, right? So we have popped out 1 comma 4. Okay. 1 comma 4. So we are popping out 1 comma 4. Okay. 1 comma 4 we have popped out. Now what we are going to do? We are going to process the neighbors of node 4. The node 4. Okay. So what we are going to do? First, we are going to process this one. 1 comma 1. Okay. 1 comma 1. Okay. So we are going to take this one, this distance plus. We are going to take this distance 1 equal to 2. Now we are going to check what is the distance at node 1. Okay. So the distance at node 1, it is 0. So definitely this particular distance, it is not lesser than 0. So we'll simply ignore this pair as we have already visited this. We'll simply ignore as we started with this only, right? Okay. So now we'll take the next neighboring node 3 comma 3. 3 comma 3 we take. Okay. Now what we are going to do? 3 comma 3. What we are going to do? So so we'll take what is the current node? Current pair is 1 comma 4. So we'll take this distance and this distance, right? So this distance is from 4 to 3 and this distance is from 1 to 4, right? So we're going to add 3 plus 1. 3 plus 1, which gives us 4. Now we're going to check the distance at this particular node, right? So we'll compare this distance with the distance at this particular position. So definitely this 4 is lesser, right? This distance is lesser with what it is currently at the position 3. So we'll update this distance array. Also, we'll add in the priority queue 3 comma 3. 3 comma 3. Okay, we'll add in the priority queue. Also, we'll update the parent as well. So from where we are coming? So from where we are coming, we got the minimum distance. From 4, we got the minimum distance. Hence, we are updating the parent. Okay. So this will be the intuition behind solving the problem. Okay. So I think when I code, it will understand, like you'll understand better. Okay. So before going to the code, I'll request you to subscribe to my channel because a lot of effort goes in solving this problem and creating this video. Okay. So let me first I'll code in Java followed by C++. Okay, so I have pre-created this pair class. Okay, for this for the Java. So I've pre-created this pair class. Okay, so here what it is, the first part of the pair is distance, and the second is node value. Okay, node itself. So first we are going to create an adjacency list. Okay, array list, right? Which will be part of type pair, which will be type of pair. Okay, so here we have adjacency list, new array list we created. Okay, now what are we going to do? We are going to create space or create, okay, the adjacency lists plus plus I. Okay, why equal less than equal to? Why we are using equal to? Because the node itself starts from 1 and goes till n. That is why. So we are going to, sorry, adjacency dot add new array list. Okay, we are initializing this adjacency list. Okay. Now, since we have been given these edges, right? We have been given these edges. So what we want to do is we have been given these edges, right? 1, comma, 2, comma 2, right? So we want to transform these edges into adjacency list. Okay. Okay. So that's what we're going to do here. So again, for, so what we're going to do? We are transforming. No, this will go till m edges, right? There are m edges here. There are m edges here. So what we're going to do? Adjacent list dot get edge of I, I of 0, edge of I of 0. So what we are doing is we are adding, for example, if we take 1 to 2, right? So what is one here? No, one is from node, two is to node, and this is the distance from between 1 to 2. So we are adding this particular node into this as a neighbor, into as a neighbor of this one. Okay, that's what we are doing here. So add. So we're going to add what? Pair. So the first part of the pair, it is going to be the distance, edge of I, right? I of 2, right? And the the destination, the node, the two node basically. Okay, so that's what we are doing here. So what we are doing here is, if you see here, right? So what we're doing, this is the source node. And what we're doing here is we are creating a pair. We are adding a neighbor to the source node. What we are adding? So we'll take this distance first, 2, and this node then. Okay, the neighboring node. Okay, 2. 2 comma 2. That's what we are doing here. Okay, that's what we are doing here. Okay, and also we'll add vice versa as it is undirected graph. Okay, it's an undirected graph. 1. Okay, and this will be 0. So what we are doing here is we are doing this. So we did this now. So we also want to add this one as a this one as a neighboring node of 2, right? As a neighboring node of 2. So we'll keep the distance as is, and it will be 1 as a neighboring node. Okay, that's what we're doing here. Okay, so I hope you have got this. Now what we're going to do, we are going to create distance arrays. Distance arrays, new int n plus 1. We did this. And also what we're going to do, we are going to take a parent array for the path. Okay, parent array. Let's name it. We are going to initialize this. We'll start with 1 because the nodes are starting with 1. We'll ignore 0. Less than n will go. Equal to n will go plus I. Okay, plus I. Now what we're going to do? Distance of I equal to, will represent this integer of max value as the as a infinity. Okay, and parent node, for each node will initialize uh, the given node as a parent node, of itself. Okay, so parent of I equal to I. Okay, we did this. We have initialized the distance and parent arrays. Now what we're going to do, we are going to now form a priority queue. Okay, priority queue of type pair we want, right? PQ equal to, sorry, PQ equal to new priority queue. Okay. And what you want to do is you want to create a minimum heap, right? That is when we pluck out an animal or pop out an element, then the pair with minimum distance should come out, right? That's what we are doing here. We are making sure A dot, so this will compare, right? And sort according to the minimum distance. B dot this. Okay. So we have created a priority pair. Now what we're going to do? We are going to add this. Okay, the first pair, as we are starting from node 1, right? So since we are starting from node 1, the distance from node 1 to 1, it is definitely going to be 0. So we have added the distance and the node pair, and also we'll update this 1 equal to 0. Since we're starting with node 1, the distance from node 1 to 1, it is going to be 0. Okay, now what we're going to do, we are going to now iterate. Our priority queue is empty. Okay, so we'll keep running this while loop until the priority queue is empty. Okay, now we'll poll the element, right? Pair current equal to pq dot poll. We will remove the pair with the minimum distance. Okay, so now we'll have a current distance, which is current dot dis, and current node equal to cur dot node. Okay, now what we're going to do? So we will process the neighbors of this current node. Okay, we are going to process the neighbors of this current node. So what are we going to do? Pair neighbor equal to adjacency dot get current node. So we will process or iterate the neighbors of the current node. Okay. Okay. Now what are we going to do? We are going to check. We are going to check the distance. Okay. We are going to check the distance nbr dot dis plus the current dis, right? If it is lesser than the distance at current node, sorry, the neighbor node, right? nbr dot node. If it is lesser, that's what we are doing here, right? That's what we are doing here. So when we were updating this infinity, what we are doing here is, see here. So there was this pair. 1 comma 4, right? 1 comma 4. So what was a neighbor of 4? This node. This was one of the node, right? 3 comma 3. Okay. So this is the current pair, right? This is a current node and this is a current distance. So what we do here, current distance. So current distance plus neighboring distance, 1 plus 3. Okay. 1 plus 3. We are checking in. We are checking in this. We checked in this, right? We checked for this 3, right? For this 3, for this neighboring node, what is the distance, right? Okay. If it is lesser 1 plus 4, definitely then we had updated this infinity, right? That's what we are doing here. That's what we are writing the code here. Neighboring distance plus current distance. If it is lesser than, then we will update. Let me copy this. We will update. Okay. What we're going to update, distance of this neighboring node, nbr.node. That is the node number 3. Okay. With the updated distance, the lesser distance. Also, we'll add this in priority queue. pq.add new pair. Okay. We'll add the updated distance, and what we're going to do, nbr.node, the neighboring node you want to add, right? We did this. Also, we will update this nbr.parent node, right? nbr.parent node with current node, right? So that's what we are doing here. So we had updated, right? So this particular parent node of node 3, right? Parent of 3, we updated with the current node, which is coming, right? Uh, which we are having the shortest distance from. That's what we did here. Okay. So I think this much part it is clear, should be clear to you. So we have explained this, right? Now, let me explain the, okay. Now what we're going to do is first, okay. Now what we're going to do, if we'll check, if distance of n, if it is equal to integer dot max value, right? Integer dot max value, that means there is no shortest path from, there's no path given. There is no path from 1 to n. Okay. So let me have this, the resultant list as well, path equal to new array list. Okay. So what are you going to check? If there is no path, okay, so the distance of n will still be the infinity. So what we want to do, simply path dot add -1. Okay, and simply return the path. Okay. So we are done till here. But if there exists a path, right? There exists a path. Okay. So what we're going to do? Let me explain now. After doing all this operation, the resultant parent array, right? The resultant parent array, it is going to look something like this. Okay. It is going to look something like this. So how to have this path, right? What we want to have this, the path as, for example, what is the path? What is expected? 5, right? 5, the distance. And then what is expected? 1, 4, 3, and 5, I think. Let us go up. What was expectation? 1435. Yes. So what is expected in the path? The nodes which falls into the path, right? 1435. That's what is expectation, right? Okay. Now, in order to have this path, right? In order to have this path, so we'll be getting this path from the parent array. And after doing all the operation, the resultant parent array will look something like this. Okay. So what we want to do is, what we are going to do is, we are going to have a node variable. Okay, a node variable which will initialize with n. Okay, since we want to have path till n, right? And what we'll do is, while we are going to write this code, we are going to write this while parent of node is not equal to node, right? We'll go till, sorry, we'll go till, somehow my pen is not writing. Okay, no problem. Okay, so we'll go till parent of node is not equal to node. So when we'll go till, for example, in this case, right, 1. So parent of 1 is 1. So we'll run this while loop till this condition is not satisfied, right? So for example, let's say, now let's have this path as a resultant list. Okay. So what we're going to do, we're going to add. So for example, parent of node, what is n? What is node now? Node is 5. So parent of node, what is node value? Node value is 5 and parent of node is 3. So they are not equal. So we are going to add path dot add. Okay. Node we are going to add. So what we added here? So node, right? We added 5. Node value is 5. And then what are we going to do? So node equal to, okay, node equal to parent of node we are going to do, right? We want to trace this in the reverse order. So what we are doing is, see, parent of node. So just you'll understand what we're doing here. Okay. So what we're doing is, after adding this 5, we are saying we are assigning parent node to node. So what is parent of node? Parent of node is 3. So we are assigning 3 to this node. Okay. And what we are doing here in the while loop, we are going to check if parent of node, what is node? Node is 3, right? So parent of node, what is parent of node? It is 4, right? Is not equal to node. Node is 3. So if it is not equal, so simply add 3. So we are going to add 3 in this. Okay, we are going to add 3 in this. Okay, and then what we are going to do? Parent of node we are going to assign to the node. So what is parent of node? It is 4. Okay, it is 4. So again, we'll go to the while loop. We'll check what is parent of node. Parent of, see, node value is this 4. Parent of node is 4. 1. Sorry, 1. 1 is not equal to 4. So we are going to add what? We are going to add 4 to this list. Okay, we are going to add to this list. And then what are we going to assign? Parent of node is 1. We are going to assign 1 to the node. We are going to assign 1 to the node. Okay. So here, now this condition will break because node value is what? 1. Node value is 1. Parent node is also 1. So this will break. So we'll have a path variable as this. Okay. At the end also we know, right? Parent of 1 was always 1 because we had started with 1. So at the end we are going to also add. When this while loop breaks, we are going to add 1 to this. Okay. Once done. Okay. Now also after this we are going to add the weight, the distance, the final distance, the shortest distance. That is, we are going to add distance of n to this. So distance of n will give the shortest distance, which will be 5. So we'll add 5 here. So once done, we'll simply reverse this array or list, right? So which will give us this. Okay. So let's code. I think you'll understand. Let's code this part. Okay. So while node equal to n, right? So we'll have this r parent of node is not equal to node. That's what we said, right? If it is, then we are going to add path.add node to this, right? And we are going to assign node equal to parent of node. Okay. In this way, we'll have all the nodes in the path except for node 1, right? So which will add after this while loop. Once done, we'll add this as well. What we're going to add? Path.add distance of n. Distance of n will give us the shortest distance, as you know, right? We have already calculated here. Distance of n will give us the shortest distance till n of n, basically. And then what are you going to do? Collections.reverse. We are going to do collections.reverse path. And does it give this? Let's check. Let me compile. Okay, there are some errors. So what it is saying? New pair edge cannot find. So my bad. I have added edge when we have edges, right? Edges we have. So let me add this edges, 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 and edges we have, right? Let's compile again. Let's see for any other compiler. Okay, we have another one. Pair of. Okay, this is, it should be node, right? Neighbor.node. Okay. Okay, what else? Void cannot be converted. Okay, so this does not return the reversed list. We have to return this separately. Return the path. Okay. Okay, now we have got the answer for one of the test cases. Net submitted. Okay, the test cases seem to pass. Thanks for watching. I hope you got the solution. Please subscribe to my channel. Like the video if you've got the solution. Let's quickly see the C++ code as well. Okay, so here what we did, here we are taking this unordered map. Okay, it's like, and the vector. So yeah, so no problem. This is adjacent list we have. And then what we're doing is we are adding these edges, right? Edges, we are converting basically the edges into adjacency list. Okay, then we are having a priority queue, okay, which is a minimum heap basically to get the minimum distance node. And here we are having this distance array of n plus 1 and parent. We are initializing with -1 here. That should be fine. Then we have distance 1 of 0. And then we are pushing this, right? We are pushing this yeah, the node 1 with distance 0. And then what we are doing here is we are seeking, or we are taking the top of the first part of the pair, which is distance and node, and then we are popping that out. We are also checking if distance is greater. If distance is greater, okay, then continue. Okay, of distance node. If it is greater, then continue. No need to process. Yeah, this is an extra check. Okay, this is an extra check. Then we are processing the neighbors. We are traversing the neighbors. We are checking if the distance plus the edge weight, the current edge, if it is lesser than distance, okay, then update the distance, the node as a add the node as a parent. Okay, add the current node as a parent, and also we are pushing the priority queue. Okay, so once, for example, if there is no path from 1 to the end, then simply return -1. If there is, we have already explained this. Okay, we are adding what we are iterating through the parent and pushing this. Okay, and then what we are doing here is we are reversing this. We are reversing. Okay, we are reversing, and that's it. And also at the end, or at the beginning, right? We are also adding this distance of n. We are also adding this distance of n, return path finally. Okay, so I hope you got the solution. Okay, thanks for watching. Definitely it is going to work. Okay, please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.